Good morning, boys and girls. Today for math, we're talking a little bit more about partitioning or dividing shapes into halves, thirds, and fourths. I am on page 215. I don't know if you can see underneath this thicker band at the bottom, and I don't like how that's there now. Number 1 says compare. Which circle is divided into thirds? So we're looking at circles A and B. Remember that thirds means it is divided into 3 parts, and we write 1/3 as a fraction like this. And which circle do you think is divided into thirds? A or B? Circle A is the one that is divided into thirds. Why is it circle A and not circle B? Because circle B is also divided into 3 sections. Circle A is divided into 3 equal parts, whereas circle B is not in equal parts. So yesterday during our class meeting, we had some friends that divided their circle up using straight lines like this, and I was like, oh, it does look like it might be even. Okay, we'll go with that. Well, I talked to the other second grade teachers because I was looking at the math book and it was saying that that wasn't right. So there's only one way to divide a circle into 3 equal parts, and it is this way. So your cross can go down like a peace sign, or it can go up like a Y, and that's not in equal parts. That part is too small. But these are the 2 ways to divide a circle into thirds, with equal parts, not with straight lines. We cannot do thirds for a circle with straight lines. So circle A is the circle that is divided into thirds because the parts are equal. The parts in circle B are not equal. This intersection right here is larger than each of these end sections. And when we're looking at our fractions or our parts, we want equal parts. Parts that are the same size. Okay. Number 2 says draw. Divide the squares in half 2 different ways. Make the halves of one square different shapes than the halves of the other square. Try doing the same thing with the circles. What do you notice? Well, holy camole, that was a lot of words and it might sound a little confusing. So I'm going to show you in half an example one way. Okay, straight down the center. Again, that's not completely in half, but you get the gist. And if you do a line like this, like I'm not going to be like, oh my gosh, it's a little too much to the right. Okay, I mean, don't put it like way over here, because if it's way over here, then I'm going to be like, maybe not. But I also am not going to take a ruler. So I'll use my better judgment and you use your better judgment. So what it's saying is that it wants you to divide this square in half, but it wants the halves to be different shapes than these pieces. So I divided this square down the center, which made each piece the shape of a rectangle. Can you divide this square in half, but so that the pieces are not rectangles? So that way the pieces are not rectangles. I can think of going diagonally. Now my halves are triangles. For the circle, divide the squares in half 2 different ways. Make the halves of one square different shapes and the half of the other square. Try doing the same thing with the circles. What do you notice? Okay, so dividing a circle in half, I again can go this way. How else can you divide a circle in half by changing the shape? Sure, you can go on an angle, or you can go across, but half of a circle is always going to be the same shape. Does that make sense? So the shape of our squares can change because they have corners, and we can go from different places on the straight line. But a circle is one circled line, and whenever we divide that in half, we're going to end up with the same shapes. So what it wants us to notice is that the squares can be divided into two different shapes. The circle is always half a circle. All right, looking at explain. Carlo and Abe buy the same sandwich. Carlo's sandwich is cut in thirds. Abe's sandwich is cut in fourths. Which sandwich has smaller pieces? So I want you to draw two rectangles. Divide this one into thirds. Divide this one into fourths. Tell me which one's smaller. Okay, which sandwich has smaller pieces? I'm going to put a C here. Carlo's sandwich is in thirds, and Abe's sandwich is in fourths. Which sandwich is smaller, in smaller pieces? They're the same length overall, but the pieces are smaller. Which sandwich has smaller pieces? Abe's, right? Because when we have fewer pieces, when our thing is divided into fewer pieces, our pieces are bigger, but the bigger the pieces it's divided into, the smaller each piece is. When we have more pieces that it's divided into, the smaller each piece is. Does that make sense? Today in the math review session, I will talk about this more too if you need help with it. Shira and her mom make 3 pizzas for a party. This has 2 parts, okay? So this is our circle pizza, this is our rectangle pizza, and this is our square pizza. Shira will have 10 people at the party. Draw how Shira could cut each pizza into halves, thirds, and fourths to get exactly 10 pieces of pizza in all. So one of these pizzas needs to be cut into halves. One needs to be thirds. One needs to be 4. 4 plus 3 is 7. 7 plus 2 is 9. How does that make sense? Just kidding. I don't like the way they worded this question. So, we're using halves, thirds, and fourths to divide these pizzas, but we're not necessarily cutting 1 in half, 1 in third, 1 in fourth. That's what I did over here. If I have 4 pieces of pizza plus 3 pieces of pizza, I have 7 pieces of pizza. If I add 2 more pieces of pizza, I only get 9. So I can't cut 1 into halves, 1 into thirds, 1 into fourths. I will be 1 piece of pizza short. Okay, so we need to figure out how we can cut these pieces of pizza. Knowing this is 1/4, 1/3, 1/2, and I'm only 1 pizza short, if I change this half to a third, right? 7 plus 3, 7, 8, 9, 10. So this tells me 1 pizza needs to be cut into 1/4, and 2 pizzas need to be cut into 1/3. This is where my brain went with this. I'm not sure where your brain went. You won't have to do this on the test either, just so you So let's practice. Pick one of the pizzas, divide it into fourths. Pick the other two pizzas and divide it into thirds. Dividing a circle into equal thirds is not easy, so I'm going to decide to do the circle into fourths, because that's easy peasy. Doing the rectangle into thirds-ish. Doing the square into thirds-ish. Okay. Sarah asked more people to the party. Now there will be 12 people. Draw how Sarah could cut each pizza into halves, thirds, or fourths to get exactly 12 pieces of pizza in all. So let's look at what we did up here. We have one in fourths, 2 in thirds. We have 10 pieces of pizza. Now she's inviting 12 people. So we need 2 more pieces of pizza. Well, if I look at, I have 2 thirds. If I add 1 more piece of pizza and make those 2 thirds fourths, what is 4 plus 4? 8. And what is 8 plus 4? 12. So I could cut all 3 of these pizzas into fourths and have 12 pieces of pizza. I feel like this is confusing. How are you guys feeling about this? Can equal parts of a whole be different shapes? What do you think? Can equal parts of a whole be different shapes? Think back to the square that we divided in half. Can equal parts of a whole be different shapes? Sure they can. However, it depends on what shape you're dividing, what the shape of the whole is, because look at our circle. Well, look at our circle up here. We have 4 pieces. Can equal parts of a whole be different shapes? Oh. JK. I misinterpreted this. Can equal parts of a whole be different shapes? Look at all of the shapes, all of the 4 pieces of our circle, all 4 pieces of our rectangle, all 4 pieces of our square, the 3 pieces of our rectangle, the 3 pieces of our square, the 4 pieces of our circle. They're all the same shape, right? So all 4 of these pieces are a triangle. They have 2 straight lines and then this curved line. All 4 of these pieces are the exact same shape. Looking at our rectangle, all 4 pieces of our rectangle are squares. Looking at our square, all 4 pieces of our square are smaller squares. So, equal parts of a whole cannot be different shapes from each other. That's still not right, because if you remember back to our I Ready video, where they divided the circle into, how did they do that? Oh, it wasn't a circle that they did. It was a, you can't see this anyways. It was a square where they had 2 squares and then 2 triangles. It's still in fourths. What is that equal parts? Lord have mercy, I have no idea. Can equal parts of a whole be the same shape? I don't know. What do you think? You tell me what you think, and I'll figure out the answer, and I'll tell you the right answer. But I want to know what you think first before I tell you the right answer. What do you think to this question? Can equal parts of a whole be different shapes? Yes or no? And tell me why you think. I want to know your thinking too. Okay? And I'll come